Hi everyone. So it's really great to be at BruCON. Our talk today is about the research we've been doing into DNS from both sides, below the recursive and above the recursive, and how we developed a unified view of DNS traffic to track internet threats. So who am I? I'm the technical leader, senior security researcher at OpenDNS. So my focus is on graph algorithms and how to apply them in our kind of massive amount of data to extract patterns and detect threats.
My name is Mathew. I'm a security researcher at OpenDNS, and my background is in machine learning and kind of time series analysis.
And the outline in a nutshell would be something like this. So we'll start with an overview of OpenDNS's kind of global view and the type of traffic we deal with. And then we'll kind of cover the threat landscape that we are focusing on. And then we'll talk about the actual methods of traffic analysis. And then we'll discuss some very interesting results that I hope you'll like. And then we'll also look at another major part of this research, which is studying the hosting infrastructures of these kind of malicious domains that we catch with traffic analysis methods. And then we'll have a conclusion and we'll open it up for questions. So this is kind of the worldwide map of our resolvers. So we have 25 data centers with 100 plus recursive resolvers on 5 continents. And that allows us to see a lot of traffic. And it's very useful to kind of see, have a good perspective into what's happening on the internet. And the DNS traffic we deal with is actually of 2 types.
So OpenDNS sees both recursive as well as authoritative DNS traffic. And DNS is the protocol that helps us map a domain name to an IP. And authoritative traffic is kind of the global repository of all the official mappings between a domain name and the IP. And then the recursive traffic refers to an individual client's DNS query, and then a recursive resolver, in this case OpenDNS, then goes to the authoritative server and fetches back the record. So these are 2 distinct types of data traffic that we're dealing with when it comes to DNS traffic, and both of these are extremely valuable.
So having said that, let's take a look at the threat landscape that we are trying to cover here. So if we're talking about cybercrime or kind of malware that is trying to, with which the bad guys are trying to kind of make money, financially motivated cybercrime. So usually you're trying to infect as many machines as possible with a variety of malware kind of pieces. So it could be a crypto ransomware, a banking Trojan, all kinds of bots for DDoS, spam, ad fraud, or like some fake software to force you to kind of call a hotline and pay money to fix your computer. So all of these attacks or all of these malware to get implanted on your box, usually they are delivered via what we call like exploit kits. And to end up on the exploit kit and drop the malware, you'll have to go through another earlier stage, which is visiting like a popular compromised site or like a malvertising campaign. And sometimes you'll be sent like a phishing spam email where they ask you to open up an attachment, like some of the Walmart or UPS alerts, and if you click on it and open it up, then you get the malware dropped on your machine. So our focus in this research is to kind of detect the patterns that are typical of exploit kit landing domains. And we'll show how if you analyze DNS, you can be very successful in kind of zero in on those types of attacks.
So before we talk about some of the methods, it's useful to talk about the scale of data that we're working with, because that'll put the methods into perspective. So we see about 70 billion DNS queries per day. And so that translates into about half a terabyte of data per hour that needs to be kind of processed. Furthermore, if you just took a sample of our authoritative data and kind of transform that into a relational graph, you would have around 46 million nodes, as well as 174 million edges between those nodes. And the nodes represent a domain IP pairing, and edges represent some sort of relationship between nodes. So with this many kind of nodes, it's really an example of a needle in a haystack type problem, because it's just far too many nodes for an individual or even a group of analysts to quickly identify a potential malicious domain. And that's why we need to develop some automated techniques.
Exactly. So the challenge here is to have automated methods that can be scalable and efficient at the same time. So let's take a look at some of these DNS traffic analysis techniques.
So the classic kind of DNS data that people are familiar with working with is called authoritative data. And I'm sure some of you have heard of passive DNS databases. And a passive DNS databases use authoritative data. Authoritative DNS data is a historical kind of mapping of a domain to IP pairing. So for example, I could see all of the IPs that google.com has mapped to for the last 1 year if I'm keeping track of all my authoritative data. So it's really useful for a historical view of a domain's kind of IP history. As a result, this type of data is extremely helpful in catching kind of three types of badness. The first is what's called a fast flux domain. A fast flux domain is a domain that continually changes its IP mapping in a matter of seconds. This is used by a lot of botnets and Trojans, so they can evade capture by the authorities. Also, many researchers enjoy using authoritative data to help them create domain reputation mapping, so they can kind of see that if a certain IP range is considered bad and a domain maps to it, that domain is probably also a bad domain. And this can then be expanded into the idea of a prefix reputation. Essentially, authoritative data is helpful to kind of see how an IP relationship with a domain can be somehow associated with some measure of badness. So the most popular method is domain reputation, it was talked about. And it's kind of a method that's been used for the last 10-15 years by security companies, where there's some sort of complicated formula involved in identifying whether a domain is good or bad. So they look at the reputation of the IP, the registrar, the registrant email, and some other crazy terms, and then they come up with the score. And then if the score is over some threshold, they add it to the blacklist. So the problem is this was a method that was developed around 10-15 years ago when the internet and hosting was considerably different. And as a result, while domain reputation has its place, there are a new category of threats that are able to easily evade classic domain reputation. And for example, many times DGAs or domain-generated algorithms are able to create a slew of new domains really quickly, and authoritative DNS is unable to properly handle them. Secondly, there's also a class of domains that maliciousness can only really be inferred by looking at the client behavior as they interact with the website. So as a result, we have noticed that exploit kits have used compromised domains, which many times are associated with domains that have a good reputation, yet will then fly under the radar of a domain reputation algorithm because the domain that they're kind of compromised, everybody thinks is good. And finally, the price of domains and subdomains have gotten cheaper, so it's easier to flood the market with a ton of domains that have no reputation, so you can't even make a prediction. So we decided that there could be a couple of techniques to help us identify potentially malicious domains that didn't rely on authoritative DNS. And we wanted to look at the DNS query patterns. In particular, we thought that DNS query patterns are a signal that are harder for the attacker to control. So more particularly, we wanted to see whether we could use DNS query patterns to identify exploit kit domains, because we believe that there's a very specific signal between an exploit kit domain and their DNS query pattern from the client, from the user end.
And the idea here is that the signals of these exploit kit domains or other types of attacks, they have inherent versus acquired or assigned features. So if you're talking about certain malicious domains, the lexical makeup is kind of sometimes used as a feature to detect them. If you're talking about DGAs, you'll have like a seed, you also have a time granularity, whether it's like the minute, the hour, or the day that will be used internally to generate the domain name. There's also like the hosting, whether it's IP, prefix, ASN, And also the registration, like what type of registrars are you using? So those are all like features that the attacker will try to kind of change so he can evade detection and kind of being caught. The thing is, those he can control. However, there are certain patterns that develop or emerge globally from the infected machines or the kind of would-be infected machines that he cannot control. He cannot obfuscate, for example, certain time elements or certain geographical kind of features of the clients that are looking up these malicious domains. So our objective here, or like the premise, is that we want to defeat these malware campaigns by looking at these features that are very hard for them to defeat or evade. And that's kind of the novelty somewhat of this research.
So the general idea is that there can be significant changes in query patterns that could be correlated with malicious domains. And we're able to gather this data by looking at DNS traffic from below the recursive layer. And this type of data contains 6 pieces of valuable information. There's a timestamp, a client IP, the domain queried by the client, the resolver queried, which gives us a geographical location, as well as the query type, or a queue type. And this then leads us to building.
So the kind of the system we are developing here goes like this. So the block diagram looks like a spike detection algorithm in the beginning. So you'll get like an input of hourly logs that you run the spike detection algorithm on, and then you get like a large set of domains as the output. But then you'll have to clean up that set further. So what we apply is a domain history filter that I'll explain later. And then from that, you'll have like a couple more filters that are kind of forked at the same time. One is based on queue type that we receive in the queries, and the other one is some sort of an active probing, where you check whether the domain has specific records. And the combination of those two, they will allow us to kind of decide whether this domain is an exploit kit, a potential exploit kit, it's a fake software, browlock, phishing, DGA spam, etc. Now, having obtained that final set, which is quite refined, we still need to kind of expand the intelligence graph. So what we do, we pivot around the IPs, the ranges, the ASNs, the smaller hosters, the registrant emails, any kind of indicator that you can extract from that set that will help you kind of identify other things and enrich your kind of graph. So, and the process can keep going like in different hops as much as you want.
So as I mentioned earlier, the traffic pattern that we're kind of looking for is a spike in traffic. And we define a spike as a particular jump in traffic over a 2-hour window. However, we also have calculated a threshold score that the spike needs to cross in order for it to be considered like a valid spike. And this helps us filter out high traffic domains like Google, Facebook, the New York Times, or domains that might naturally have a spike because they're popular websites and they post something that attracts a lot of followers. So as a result, we're only kind of looking for domains that haven't received a lot of traffic in the past and then suddenly start to exhibit spikes in their traffic pattern behavior. This entire job is done by using a MapReduce job, which helps us calculate the domains that have spiked. The problem is we still end up with around 50 to 100K domains to inspect. So we're not yet fully done. So this is an example of kind of 2 exploit kit domains and their traffic patterns, as well as an example of kind of the types of spikes that we're hoping to extract from the DNS query logs. So because the majority of the 50 to 100K domains are not malicious, we need to add some more features. In fact, when we started to look through the domains, we noticed that many domains belong to mail servers or random blogs, and also included what we call victimized domains. And so this is an example of a victimized domain that participated in a DNS amplification attack. Essentially, people spoofed a series of DNS any requests to this domain, and this domain then responded with a much larger packet response, and the spoofed people received then these very large DNS packets that overloaded their network capacity. So that's just an example of a domain that it's not necessarily, it shouldn't be blocked, but it's just being victimized by miscreants. So as we mentioned, we just can't rely on the spike alone to help us filter out domains. So we need to kind of look at the spike as being more than one kind of dimension. So we want to add kind of extra dimensions into modeling the spike better. So one type of feature that helps us get a better idea of the type of spike is looking at the DNS query type. And so every time you send out a DNS query, there's a query type that is associated with that DNS request. So for example, let's say that you're interested in knowing the mail server IP address at google.com. You would send a DNS query of type 15, which refers to an MX record. There's also then 4 other DNS query types that we look at. 16, which is a text record. 99, which is an SPF record, which deals with mail authentication. And then a 255, which is an any record. So the idea that we had was, why don't we look at all of the spikes that have been generated and then partition them into various pairings of DNS query types. So in this case, the total number of partitions that could exist is 31, because we just sum up over the number of possible combinations, in this case being n choose 5, where n ranges from 1 to 5, and we can then see all the various combinations that it can exist. So for example, does a certain domain that's spiked receive DNS query types of 1 in 15, or does it receive DNS query types of only 1? What's interesting is that there's some very specific distributions that are associated with the partition. For example, 75% of all the spiked domains only received A queries. And many times we don't even see DNS queries of a particular type. For example, the Q-type 99 never existed. And we've been running this study for about the last 8 months, and we have yet to see a single DNS query of just type 99 occur in a spike domain. So what this kind of gave us hope is that this type of partitioning can help us associate partitions with the behavior of the spike. So I'm going to walk through some of the examples that we found. So for example, a Q-type of 1 in 15, that means a domain that spiked received Q-types of both 1 and 15, belonged to basically one class of family, which was legitimate mail servers. And even within this legitimate class, there were 2 types of distributions. So for example, you could have a domain that spiked to say 100, and then 50% would be of type DNS Q type 1, and 50% would be of DNS type 15. And then there was also the 99-1 split, where 99 was of Q type 1, and then 1 was of Q type 15. And this just accounted for 4% of all spike domains. But what was interesting was when we started to look at the larger time series for this partition, these domains began to exhibit a periodic pattern in their past query history. So we realized that domains that had some nature of periodic patterns in the past would most likely be benign domains. And this was something that we would then use when creating a time series filter later on. One of the more interesting partition types was the Q-type group that contained the Q-type partition that contained all the Q-types. And this partition was many times associated with spam domains. And what we identified was that domains that had a jump from, say, 1 to 2 to all of a sudden a couple thousand were many times associated with spam domains. So for example, demdeeds.xyz was a domain that we found out to be participating in a larger spam campaign. However, the challenge with relying on Q-types for straight kind of labels is you can't always blindly label things as spam. So for example, here's Eurovisiony.it, which also received the same, which also lay in the same Q-type partition, but it was a completely legitimate domain. Finally, there was the Q-type partition of 1, 16, and 99, which all belong to families of mail servers. So in this case, all the kind of domains that lay in this partition were somehow related by their 2LD. In this case, you can see that vpim.net.br had two mail servers that are pretty much spiking at exactly the same time. And if we looked at the previous history of these domains, we can see that they're almost identical. This was another kind of interesting partition group.
Now, having said that, remember in the block diagram, we showed that we have the spike algorithm that looks at surges in traffic between 2 hours. So when we extract those domains, before we do the Q-type filter, we apply what we call a domain history filter. This one is kind of trying to separate benign versus domains that are kind of involved in malware distribution. And what we first do is eliminate anything that has more than X consecutive non-zero hours of traffic. That's kind of eliminating all of the domains that had past history. And then we have been observing like exploit kit domains for a while, and we saw that they featured this behavior where the spike will last no more than like Y consecutive non-zero hours of traffic. And it's specific to the attacks. So what we do in the next stage is only keep the domains that have the most recent Y consecutive non-zero hours. As an example, this domain here, it had a spike when we caught it, but then when we check like the past 30 days, we'll see that it had an earlier bump like a couple of weeks ago, and that will kind of eliminate it from the specific types of attacks we're trying to catch. However, if we look at the nuclear exploit kit land and domain, we see that it has a spike, but then when we check like the last 30 days, the history was kind of all flat. So that's kind of an indication of what it's kind of repurposed for. Now, the other filter that goes in association with the Q-type filter is the active probing or domains records filter. This one is basically asking the domains we obtained from the previous stage, do they have specific DNS records? So we'll ask it if it has an A record, MX, TXT, CNAME, or name server. And each one of these will tell us something, or like a story about this domain. So for example, for certain types of compromised domains, if you see that they are having a specific name server, you will know that they are being compromised and repurposed for certain attacks. Same thing, if they are using certain name servers, we will know that they are kind of used for delivering malware. And all of these records will actually contribute to the decision at the end.
So the ultimate goal is to categorize a domain based on its partition and some information regarding its spike, and then put into various groups. So whether it's an exploit kit domain, a DGA, a spam, belonging to the BruCON family, so on and so on. So what we decided to do was to then kind of write up a classifier that could automatically kind of detect whether what family a spike domain belonged to. So this kind of brought up a larger kind of philosophical point, which was what's the ground truth that we're working with. And so in this case, the known bad that we had been collected over the span of 5 or 6 months. And so in the future, as we kind of move forward, the domains that we would catch would only kind of belong to this set. It would be difficult for us to identify, say, newly emergent domains because we have never seen any sort of kind of domain like that in the past. And that was something just for us to kind of know as we built this system. So we decided to use probably the most basic of classifiers, which is a decision tree. And so the idea behind a decision tree is to have a set of weak questions that we can kind of all combine together to provide a form of classifications. And once we go through the process of training the classifier over a training set of data, each of these questions are kind of given a certain level of weight. And so when a domain kind of passes through a decision tree, as it kind of is asked each of these questions, its kind of output response helps it kind of follow down the tree and then end up in a certain classification bucket. So what this meant was we would pass in a list of filtered domains, and then once it kind of went through the decision tree, it would be kind of spat out into nice little buckets depending on whether it's a spam domain or an exploit kit domain. So the types of features that the decision tree looked at when asking its question involved the partition class that the spike domain belonged to, the height of the spike, and the number of unique IPs. And so what we found out was passing through this list of domains with the decision trees and then spitting it out into these various buckets made it a far more manageable task. So we were able to reduce the list of 100,000 domains to actually only 50 or 60 domains. And that was something that our analysts could easily look through and kind of find true positives.
So after kind of giving an overview of the architecture and design of the system, I know you like to see results. So this is kind of the part that I find kind of exciting. So these are some of the types of attacks we catch. So like I said, exploit kits, the current ones like Angler, Nuclear, Neutrino, a lot of DGAs, also a lot of fake software, you know, like the Chrome extensions and a bunch of other plugin extensions that you receive, and also a lot of spyware, scareware, kind of like executables. And then we also have the class of browser-based ransomware. And finally, we caught a lot of phishing campaigns with this system. Now, having said that, there's another piece in the study which is recording or documenting the hosting patterns of these malicious domains. So Thomas mentioned earlier the kind of the problem of ground truth based on past history. However, if you also follow the trail of the way kind of the bad guys establish their infrastructures, that also gives you some more intelligence on how they are operating. So you can combine traffic analysis with hosting infrastructure monitoring, and it gives you like a much better perspective. Hence kind of the title of Unified DNS View to Catch Badness. So these are like some of the documented patterns. We have a lot more, but we kind of chose a few to share with you. So you have like what we call compromised domains, or what it has been called in the past few months, domain shadowing. And this is basically like compromised 2LDs, and they are injected with subdomains, and these subdomains, they are pointing to IPs that are not those of the 2LDs. And the IPs usually kind of are hosting exploit kit landing kind of domains or proxies to the actual exploit, and also used for malvertising. The other pattern we saw is that in addition to the domain shadowing, you'll see them resolving to several IPs. So it's kind of also fault tolerance here. If one IP gets shut down, then they can use the second one. And usually they are kind of spread in different prefixes and sometimes different ASNs and hosters. The third pattern is we saw a lot of the exploit kit domains and malware kind of domains being hosted on bulletproof hosting providers. And these usually are registered offshore, you know, like in Caribbean islands, Southeast Asia, sometimes in some Eastern European countries, where kind of the legislation or like the regulations are kind of lax, or they can evade, you know, abuse, responding to abuse reports, or they can take longer to respond to those kind of abuse reports. And then they also try to diversify their IP space. So if it's registered, let's say in the Seychelles, then they will try to have presence in data centers in ARIN and RIPE IP space. And again, it's kind of fault tolerance. So if they get shut down in one country, they can always use another country. And the countries will have different kind of legislations. So one will be like more strict and the other one will be lax, and they can play that game. The other one, and I'm sure a lot of you are familiar with this, you have a lot of these big providers that are heavily abused over and over again, like Hetzner in Germany, LeeSwep in the Netherlands, and DigitalOcean in both like North America and Europe. And then finally, we saw a few examples of shady hosters, like smaller scale hosting providers that are created within larger ones. And they are catering to mostly criminals. So I'll take the example of Vulture in a second. So as the first example, the compromised domains or domain shadowing. Like I explained earlier, it's kind of the 2LD injected with subdomains for delivering attacks. And as a side note, GoDaddy has been the most abused in the past kind of, I guess, couple years. And what you try to check is if the domain, the suspicious one that you caught with a spike model, has a name server as GoDaddy's name servers, you will assume it's kind of compromised and repurposed for attacks, especially if it has a subdomain on an IP that is suspicious. However, we can find some false positives. So you can find these cases where it's actually a Chinese lottery or a casino site or some spam. And this is kind of not on the same level of badness. So you cannot just like block it and say, and give it like a wrong label. However, when you look at more features in terms of Q-type, or in terms of the IP of the clients, the IPs of the clients, then you can make a better decision.
So this is an example of a spam domain and an exploit kit domain that both spiked. And the decision tree was able to correctly classify these two examples because when it was looking at the number of unique IPs, which in this case is 40, and compared that to the ratio of DNS queries, it saw that it became closer to a 1-to-1 ratio than in the case of the spam domain, which as you can see only had one unique IP, and that one unique IP generated 26 queries. So that was pretty far away from a 1-to-1 ratio. So the decision tree then realized that there was that difference and then classified both of these groups correctly.
On the other hand, in terms of hosting perspective, the exploit kit domain is hosted on this IP that belongs to this Webzilla ASN, and more specifically under this smaller hosted provider called Eurobyte.ru. And this one has been kind of used for a while for malicious purposes, whether it's abused or kind of complicit of the criminals. This is kind of the way the spike looks for this exploit kit domain, and that's kind of the Eurobyte.ru hoster. Now, taking a look at the next pattern in terms of hosting infrastructure, and as we associated with the spiky domain. So this one is still using the domain shadowing technique. So you have the domain mit.academy with a subdomain. They both, actually the domain resolves to a couple IPs, but they still belong, so they belong to different prefixes, but they are still under the same ASN. And more specifically, that IP belongs to a vps-server.ru. This is kind of a small hosting provider in Russia. Now, it's interesting how, as we said earlier, how we can follow the trail. So looking at the range of the 160, the neighboring IPs are also hosting similar EK domains. And among those IPs, one of them was hosting this other domain using domain shadowing, which was also resolving to another IP. This IP was living on hostlife.net, another Russian hosting provider, which is actually under LeaseWeb. So this is kind of the case of the big provider having smaller entities selling kind of VPSs and dedicated servers. And then when you check the range of that other LeaseWeb IP, you'll see that actually the range, the neighboring ones are also hosting similar EK domains. So this is kind of an example of at least like a 3 or 2 hops of exploration through the intelligence graph where you can catch things that you haven't caught with the initial model. And we are kind of developing a lot of these kind of micro models that help you have seeds to kind of probe the big data of DNS or IP space. Now, this is another example, another exploit kit domain, blah, blah, blah.xyz, and it resolves to this IP. So it lives on this ASN. It's actually part of QHoster. This is a hosting provider that has been also heavily abused, or I would say maybe complicit with the criminals. Now, the range of that IP, all of the IPs that were neighboring in the /24, they were delivering similar exploit kit domains. And the domains on those IPs, they usually had less than a day of lifetime, actually a couple hours. Now, another kind of technique we use, we look at the fingerprint of the IPs that we discover. And those IPs that had the same fingerprint, like they had a web server, Nginx, and then an SSH port open, and then the same operating system. Now, when you check the /24, you'll see that you have some other IPs having the same fingerprint. And then I flagged those and I said, well, in a couple, maybe days or maybe a few hours, they will also start resolving, they will start hosting these bad domains. And actually, that happened in kind of the next day where they started hosting similar kind of exploit kit domains delivering the same attack. So again, this is kind of where you try to predict what's happening, and it kind of worked out well on a larger scale. Now, another way to pivot around that domain we caught, the registrant email, actually now I believe it's protected by Privacy Protect, but then before that it had this email for the registrant. It's vcproject@.ro.ru. That was used to register a lot of these XYZ exploit kit domains. The thing is, it's also registering avdetect.com. And a lot of you are familiar with those kind of virus total for criminals services. like Scan4U is famous. This one, AV Check, is the one we caught here. I believe it existed before, but they changed their interface and they hosted it on a different IP. And this is typically your kind of interface where you can create an account, and then you can submit your samples and check whether they're like FUD or not, and make sure they're under the radar of the AV vendors of the industry. You can also submit your URLs for your exploit kit land and domains or your sample, and you'll get alerts telling you, hey, you're kind of getting caught now or starting to become seen, so try to change or crypt your malware. Now, the Q hoster of this specific case, like I said, it's kind of a shady hosting provider. When we checked its kind of what's around it, we saw that the hoster was registered in the business in Belize, like the Central American kind of exotic country. And then when we checked their IP space, we saw that they have been doing it for a while in terms of hosting EK domains, phishing, in addition to kind of mundane content. And then the IP space was diversified across ARIN and RIPE. And like we said, they try to have a presence in multiple data centers across the globe, and they will kind of tell you, hey, if you want to store this content of this type, you should choose servers in this country. And if you want to do something else, you have to choose another country. So for example, if you want to ignore DMCA, doing it in a country where you're kind of okay, or you have up to 24 hours to kind of shut down your content. And 24 hours is usually more than enough time to kind of clean up your servers and move somewhere else. So they always try to play on these kind of loopholes in the jurisdiction, or like the way ISPs operate. Now, this is another case of nuclear exploit kit land and domain. So it resolves to this IP. This is still fresh as of today, and it's hosted on DigitalOcean. Again, DigitalOcean is like a big provider. We cannot say it's like a bad one because it's catering to all kinds of customers. And this specific IP had more than 400 domains hosted for like during a span of 15 days. And the domains usually have like a lifetime of, again, like a few hours and less than a day. Now, the interesting thing is that the previous pattern we observed with nuclear from a hosting infrastructure is that at some point early in February, there was like a massive amount of domains that were registered from the Freenom registrar, and they were all like free domains using like CCTLDs like GA, TK, and a few other kind of African countries. But they had nothing to do with Africa. They were all like purposed for exploit kit domains. The interesting thing is that the name servers were registered using a compromised email, cavalierjob@gmail.com, and the name servers were hosted on DigitalOcean and AS/Vultr. I'll explain what that AS/Vultr is. In that case, the land and domains themselves, like the ones delivering the attack, they were hosted on a variety of ASNs, but most notably AS/Vultr. Now, the new pattern that we caught like recently is that they switched from having dedicated name servers to using Freenom's name servers. Again, it was easier for us to kind of pivot around the name servers because they were exclusively for the exploit kit domains. But now they are using the Freenom name servers, which can be used for any kind of domain. Because again, you can go register like 100 domains under like some exotic CCTLDs and use the name servers of the registrar. And there is no way to say everything under these NS is bad. That's kind of, you're carpet bombing a lot of things, and you'll have a lot of collateral damage. So it's kind of a loophole where they try to use and kind of adapt. At the same time, the land and domains are still hosted on Vultr and DigitalOcean. However, the other interesting thing is that they are not abusing the main ASN of DigitalOcean, because when you check DigitalOcean, it's again like a hosting provider with a large IP space, and they have at least 9 ASNs. And the ones that were abused, they were like the small ones in Singapore, Netherlands, and a couple other countries. So what's the story of this Vultr here? So Vultr is actually a child company of AS/Chupa. That's kind of the AS number. This is a hosting company in North America. And they created Vultr as a kind of a small company to compete with DigitalOcean on the affordable VPS market. So they have like actually a large IP space, like 65,000 IPs spread across ARIN, RIPE, and AppNIC. And the fact that they were like very cost effective made them very attractive for both legit and criminal kind of campaigns. So we found that they were being used for the past, I would say since like early of this year, for exploit kits, phishing, and other great content. And we actually wrote a blog last month explaining how we kind of were monitoring this infrastructure for a while. So I invite you to check it out.
Something else that we've been able to catch are DGAs using this model. And the concept behind a DGA is you are infected with a piece of malware, and this piece of malware has a domain generation algorithm encoded in it and uses the date as a seed. And then on a pre-specified date, it then generates like a list of, say, a couple thousand domains, and it then tries to connect to one of these couple thousand domains, and that domain hosts some sort of key information or it transmits information regarding some of your banking information. So DGAs are a popular method used by a lot of banking Trojans and other cyber criminals. And in this case, we were able to kind of see the initial spike on the DGA and catch it quite quickly. And unfortunately, we found out that, or I guess fortunately, Anubis Networks had already caught it and they had sinkholed it. But what we also noticed was that this traffic pattern for DJs lasts a lot longer, around 24 hours, while an exploit kit is actually only 5 or 6 hours. But what's interesting is if we look at the query patterns for DGAs, what we notice is that they're actually almost all identical in their format. So you have almost the same number of resolvers being used, client IPs, and also the distribution of resolvers. So when we create clusters of when we create clusters of domains and their kind of patterns, we notice that DJs definitely form a very tight group, because the idea behind a DJ is that you have a set of infected machines that are all calling out at the same time to the same set of domains. And so that pattern then becomes repeatable across the set of domains, and it becomes a very clear signature. As a result, DJs are pretty easily now to be identified with this method. Oh, yeah, yes. Then the other type of domains that we have seen are fake software. And so this is the type of software when you trying to watch maybe a free video or something pops up on your screen, and then something becomes downloaded, usually an executable. In this case, we found that it was downloading a Windows executable, and there were 9 IPs in this vicinity that were all hosting the same type of fake software. And then actually when we decided to kind of look at the executable, we noticed that VirusTotal had quite a bit of information regarding previous AV vendors that had marked that executable as malicious.
The other kind of thing we noticed about this one is that all of those IPs in the range, not all of them had domains hosted on them, but they all had the executable. So they were set up in advance, and you could basically grab the payload from the IPs without any domain on them. So just like wget the IP with the path. And we saw this actually since 2013 or 14, where you have a lot of IP space, having payloads without any domains, and they just wait there until domains are registered and then repurposed for a specific campaign. This is another interesting example of domain shadowing. So again, like they use those two LDs re-injected with subdomains. The IP here where it's hosted is like under this data shack ASN. It's kind of shady in the things it's hosting. So when we check that IP, it belongs to the smaller range registered by a fella called Valentin Kulayev, most likely like a fake name. But then when you check Valentin's other IPs, you'll see that he has a few other IPs from 16 to 23. Interestingly, again, like this is for kind of the amusement part, all of those IPs, they were hosting a lot of domains by this fella called Giovanni Caporasso. He's what they call like the Italian guru of offshore. So he's offering a lot of kind of advice on how to go and make business in fiscal paradise countries and kind of make money in offshore banks. And this guy is like the Italian kind of police is after him, but he's having fun in South America, delivering all of these blogs and books. And he actually has like a large number of electronic books for people to kind of emigrate to countries and make a lot of money without paying any taxes. So that was like the interesting side thing here.
We also then ran across quite a few BruCON domains. BruCON is when you are visiting a website and then all of a sudden something pops up, blocks your browser, says you need to either pay up some money or the police are going to be contacted. It's kind of like a baby crypto locker. In this case, we noticed that there were a slew of BruCON domains that were all spiking at the same time. Unfortunately, they were all hiding behind Cloudflare, so we couldn't identify their actual IP address.
And these specific ones, they were all like Russian police force themed, like MVD and FSB kind of alerts. The other kind of the final set of malicious domains we want to kind of discuss here is phishing. So this one we caught like a couple weeks ago. It's an Amex phishing campaign. And we caught like the initial spike as it happened in our logs. And this is kind of the distribution of IPs and resolvers. So you had like around 1,300 queries from 400 plus IPs, and they were asking 16 of our resolvers. So it was quite kind of widespread in the entire world here. And now when we check the IPs where these domains were hosted, they were again all over the place. And the thing is, we tried to pivot around the IPs and also the registrant emails used for registering these domains. And you would expect to find some other badness. In this case, we found like some Nova Scotia Bank phishes and also Royal Bank of Canada phishes. And also a bunch of other cardant sites registered on with the email like private zone, mcduck.cc, and mrbin.dw.
Unfortunately, we also run into false positives. So these are two examples of false positives that we run into. And this is an example of Chinese SEO sites. In both of these cases, we were able to identify them as false positives for two reasons. The first was actually a lexical reason. These domains contain a little bit of pinyin, and pinyin is the romanization of Mandarin. So certain kind of character strings in like Uiwa Dedict actually have Mandarin meanings. And the second was if we actually looked at the IP distribution, we could see that the IPs participating in visiting these domains were also visiting other Chinese SEO domains that were also spiking within the same hour.
All right, so as a conclusion, we kind of try to share with you this unified view of into DNS to catch threats. The idea is that we try to use the DNS traffic, we try to use like a lot of things. So one of them, which is the purpose of this talk, was using stuff below the recursive, like all the traffic patterns you can catch below the recursive, and then combine that with looking at the hosting infrastructures. And that gives you like a better perspective of what's going on the threat landscape. And like we said earlier, a lot of these models that use below the recursive or above the recursive, since we have a lot of data, like the DNS kind of platform we have is quite massive. And the idea, you have to develop a lot of micro models to kind of help you detect these little seeds that then you can expand with a graph approach to catch more badness on the internet. So our approach is kind of we use content, but it's much less than the patterns that emerge. So we're kind of URL and content agnostic here. That gives us a lot of advantage, but you also need sometimes to verify with URLs and content analysis. And that's kind of the philosophy here that we kind of advocate. You can go and check some of our other references. So we had a blog about the IP infrastructure and domain shadowing. We had a couple talks at Black Hat and DEF CON and Virus Bulletin, and then the spike model was discussed at B-Sides of this year. And we had a blog discussing the combination of different models. So I'm not trying to advertise anything, but if you like this kind of research, we're hiring, so talk to us, and you can join our team. We'll be very happy to tell you what we are doing. And that's it. So thanks again for your attention, and feel free to ask questions.
Thank you for the presentations. Just one question. I suppose you have a huge data set of sinkhole IP addresses. Have you done some research to see how long it takes for sinkhole of a domain? So how long it takes that the domain is coming from being malicious until sinkhole?
You mean how they switch from?
Yeah.
So we haven't done a specific kind of research project on that, but every once in a while when we run into domains that are sinkholed, we try to see, like, expand from the IP or the name server and see what else is kind of being, like, for example, for Anubis networks, they sinkhole a variety of things. So I don't know, like, you cannot just say the sinkhole is used for sinkholing a specific attack. It's usually like a big company, and you know, they try to target, they try to kind of take down a variety of malicious campaigns. And was that your question?
Yeah, the only thing is I was wondering if you find a way to group the IP or the things that are related, for example, to Angler, exploit kit or whatever, to group them by a specific group and to see how long it takes to be sinkhole, and if you can basically use this as a classification scheme. So
for EKs, we haven't seen any sinkholed EKs, because usually they're very short-lived, and I feel like it doesn't help much to kind of to sinkhole them. Yeah, sinkholes are usually, in my opinion, used for domains that you know, either like you extract them from the malware or you know them from the DG algorithm, so you can go and just proactively kind of try to sniff the traffic from infected machines. But as for EKs, I don't think it would help much.